Why does math sometimes feel like you're just banging your head against a wall? We're always told to just practice more. But what if I told you the problem isn't you, but your textbook? Today, we're going to pull back the curtain on the hidden connections in math that your books are probably hiding and show you how seeing them unlocks some seriously powerful shortcuts.
You know that feeling, right? You absolutely crush the chapter on number patterns, you feel like a genius with linear functions, but then the exam throws a question at you that mixes them both together and your brain just short circuits. It's so frustrating, but it turns out you are definitely not alone.
In fact, this isn't just a hunch or a feeling we all get. It's a full-blown educational mystery that experts in South Africa were trying to solve. For years, they saw students struggling with this exact same issue on exams, and they finally decided, okay, we got to figure out what's really going on here.
And what did they find? Well, official diagnostic reports all pointed to the same thing. The questions that students were bombing the most weren't always the hardest ones. Nope. They were the ones that required you to connect different ideas, to see the hidden threads that tied different parts of math together.
This led a couple of researchers, Divwo No and Rena Durand, to ask a really brilliant question. They thought, wait a minute, if students are missing all these connections, could the problem be the main tool they're using to learn? So they decided to do something simple, crack open the textbooks and see what was inside.
Their whole investigation hinged on this one big idea called relational understanding. Now, that might sound fancy, but it's really simple. It's the difference between just memorizing how to do something and truly getting why it works. It's about knowing not just the what, but the why.
And this analogy just explains it perfectly. On the left, you've got instrumental understanding. Think of it like knowing a single bus route to get to work. It gets the job done, but that's it. Now, on the right, relational understanding, man, that's like having the entire city map in your head. You see how everything connects, you can find your own shortcuts, and if there's a roadblock, no problem, you just find another way. That's the goal in math. But the real question is, are our textbooks actually giving us that map?
So the researchers got to work. They took two super popular math textbooks in South Africa and dug into the chapter on number patterns. They were looking for one very specific thing. How often do these books actually point out the connections to other math topics? The answer they found was, well, it was kind of shocking.
Just look at this number for a second. 90%. Let that sink in. What in the world do you think this number represents?
That's the percentage of textbook material that was taught in complete isolation. More than 90% of the time, number patterns were treated like their own separate little island, with absolutely no bridges built to connect them to other massive topics like functions or algebra or graphs.
And if you're a visual person, this chart from their study just says it all. See that huge bar there? That's no connections. Every time a concept was taught all by itself. And that tiny little sliver next to it, that's when they made just one single connection. I mean, look at that difference. It's not even close.
The researchers themselves basically said that when you teach like this, in these separate boxes, you're making it almost impossible for students to build that city map in their heads. It's like you're just handing them a long list of bus schedules and then, come exam time, you say, okay, now navigate the whole city. Yeah, good luck with that, right?
Okay, so enough about the problem. Let's get to the good stuff, because this is where it gets really cool. What happens when we actually see one of those connections? Let's unlock one of the shortcuts that's been hiding in plain sight this whole time.
All right, have a look at these two. On the left, the formula for an arithmetic sequence. On the right, the equation for a straight line. I know, they look like they're from completely different worlds. But look a little closer. Zero in on the d on the left, the common difference, and the m on the right, the gradient or the slope. Do you see it?
They're the same thing. They are literally the exact same idea. The common difference, which is how much a sequence jumps by each step, is mathematically identical to the gradient, which tells you how steep a line is. It's just two different names for the same exact concept.
And right now, you might be thinking, okay, neat trick, but so what? How does that actually help me when I'm stuck on a problem? Well, this is where the magic happens. This is a real deal shortcut.
Okay, check this out. A textbook problem might ask you to find the common difference between two terms that are really far apart, and it'll make you do all this complicated algebra. But if you know the secret connection, you just pretend those terms are points on a graph. Then you just use the simple gradient formula, the one you've known for ages, and boom, you do a quick calculation, and there's your answer. No messy equations, it's faster, it's easier, and it just makes more sense.
And get this isn't just some one-off trick. The same deep connection is there for more complex stuff too. It connects quadratic sequences to the turning points of parabolas. It's another one of these amazing shortcuts, just sitting there, waiting to be found.
So, what's the big takeaway from all of this? I think it's that we have to change the way we look at math. We've been taught to see it as a long list of rules to memorize, when we should be seeing it for what it really is, a network.
So, let's wrap it up. The most important thing to remember is that math isn't just a bunch of separate chapters. It's this beautiful, connected web of ideas. The problem is, our textbooks often hide the map from us. But when you learn to see those connections yourself, that is a legitimate problem-solving superpower. And that little shortcut we just did, that is what relational understanding feels like in action. So I'll just leave you with this one final thought. If this simple, powerful connection between sequences and graphs was hiding in plain sight the whole time, it just makes you wonder, what other shortcuts, what other amazing secrets are buried in the math you think you already know?